Hello and welcome back, guys. It's been like 2 weeks since the last video, which we covered the final exercise in part four. I had to lock in the real world with work. I'm also interviewing for a couple of jobs, so I had to just prepare for those interviews before I could resume doing extracurricular activities like recording these videos. But I haven't forgotten about this course. I haven't forgotten about you guys. I know that I've gotten some comments from people who have been following and supporting the videos. Thank you so much, first of all, to those folks. Your comments mean so much to me in terms of giving me the motivation to continue to do this, to continue to make these videos. So I'm going to continue to deliver as often as I can. In this video, we're going to start with part five. Again, we wrapped up part four in the previous video. So we're going to start part five, section one. This section only has 7 exercises. The entire part five has only 27 exercises, so it's a little bit less than what we went through in part four. I think part four had like 35 or 36 exercises, so we get a little bit less in here. And all of part five covers a little bit of what we've already went through. I briefly just skimmed through section one, and we're going to learn a little bit about, we're going to work with lists a little bit more. We're going to also learn about nested lists. If you watched the video covering the previous, the last exercise in part four, my solution was using nested lists like this. So in this section, we're going to learn about nested lists a little bit more and what they can be useful for and things of that nature. But yeah, this whole section is just going to be about working with lists a little bit more. And then there's a couple more other new topics that we're going to learn, and also tuples, which are another really common and data type that you'll come across in programming, not just in Python, but in many other programming languages. I've gone through tuples in Java, in C++, in JavaScript. So yeah, one of those core, I shouldn't say core, but one of those staple data types that you'll definitely come across in your programming journey. Okay, so section one, more lists. In this section, the learning objectives are that you will be able to create lists with different types of items. You will know how to use lists to organize data, and you'll be able to store a matrix as a two-dimensional list. So this is the nested lists. This is just some info about the exercises on this course. It says becoming a proficient programmer requires a lot of practice, sometimes even quite mechanical practice. It also involves developing problem-solving skills and applying intuition. This is why there are a lot of exercises of different kinds on this course. Some of them ask you to quite straightforwardly apply what you have learned in the material, but some of them are intentionally more challenging and open-ended, and we've come across this multiple times so far in the course where and this is one of those things where you don't want to be too rigid. I think one of the differences between doing this self-paced course versus if you were to do this as in a university setting or a collegiate setting where you have a professor constantly teaching you material, and the subsequent exercises or homework you might get in that course will usually be very closely related to the material that you just covered. And again, so that's why you start off learning the basics, how to create a file, how to write comments, how to write your first function, et cetera, and you're building on towards being able to write a full-fledged program. So some of these exercises that we've seen, I tried to, when I'm working through my solution, I tried to keep the solution as close to what we've learned so far as much as possible. But when we take a look at the model solutions after we've submit our solution from in the videos as you're watching along, you sometimes see that my solution tends to be either a little bit more rigid, closer to the recent material that we've learned, but the model solution tends to be a lot more flexible. They'll use, we might have, like, say, for example, we just covered for loops, but the exercise might not specify exactly what you need to use, but you just have to get to a certain output, and the model solution might use a while loop. Or we could write a fully extended if statement, right? Like if this number is less than this one and it's greater than that one, then do something. But the model solution might have just an if statement that starts, that has its cutoff at the higher end down to, what the current value of that helper variable is. So that's one of those things that you'll notice when you're doing this course, is that some of the exercises might be, the solutions might be a little bit more rigid, and some of these other exercises, the solutions might be more flexible and more open-ended. So this is one of the things that in my mind as well as I'm doing this course and I'm making these videos, that I have to remember that sometimes, it's not about, and this is again when I was giving somebody advice in the comments when they were asking for help in terms of what should they focus on, and I told them, start first learning the logic in Python, right? Learn your conditionals, learn how to make functions, learn your loops, learn your lists. And then when you start doing leak code or coding bat or HackerRank or whatever, then you can start worrying about, once you do those logic questions a lot, then you can worry about efficiency, right? How can I make my solution perform a little bit better or a little bit faster, and things of that nature. But this is one of those other aspects where sometimes you have to just be like, hey, how can I just get to the solution first, and then I can go in and start refining it and making it, either if my goal is to make it a little bit less complex. If my first solution was very complex and very verbose, okay, I go back in and I revise. How can I make it a little less verbose? How can I make it a little bit more straightforward, a little bit simpler, right? Or how can I just abstract certain things where I have one big function that's doing a lot of things? How can I extract certain steps in that function and make those into their own functions, or let them run in the main function, right? So things of that nature. So sometimes you just have to get to the final answer and then come back and start revising what you have. So hopefully that makes, that was a little bit of yapping, but this is, I think that was an important thing to emphasize. Some of the exercises might at first seem overwhelming, but this is nothing to worry about. None of the exercises is strictly mandatory, and in fact, only 25% of the points in each part is required to pass the course. Again, this is another one of those points we covered earlier in the course, that, in each section that you go through, or in each part, you just have to do 25% of the material. So you can choose, but if you notice that in some of these exercises, so far we've done quite a lot. So I have like a bunch of exercises that I can do without having to worry about if I've done enough so far, because we've done every exercise up until this point. But yeah, you can do 25% for each part, and you'll still pass the course, right? You don't have to go so in depth. If maybe this is just a refresher course for you, you know Python, you've worked with Python in the past, but just haven't touched it in a while, and just need a quick refresher. So you're just kind of jumping from section to section, right? You want to go, oh, how do I write functions? How do I work with lists? What are some other methods that come embedded into certain data types that I can, or certain value types that I can go ahead and employ, right? So you only have to do 25% or get 25% of the points in each part to pass the course. So you don't have to go as hard as the rest of us in trying to finish the entire course from start to finish, but that's one of your flexibility. And again, this is one of those things where sometimes you might have seen even in the previous video, where the video before the last one where we worked on the last exercise in part 4. But when I was looking at that final exercise in the video that covered all the other exercises, I was like, hey, this is a little bit of a lengthy exercise. So maybe I should think about it a little bit more off video, and then come back to it when I have a better visual of it in my head, and then go and do it. This is the sort of the beauty of self-paced courses like this, where you have the luxury of saying, hey, this one's a little bit tricky. Let me take a little bit more time to think about how I want to attack it before I start putting code on the screen. So yeah, you don't have to get it the first time around, right? One of those things where it's one of those human instincts when you're learning something, when you want to try something, is you want to get it right the first time. I think in programming, if you get that idea out of your head and just be like, hey, let me give myself the time and grace to be able to actually do the work, or just approach it in parts, right? You go through the exercise. Okay, this exercise I have to do A, B, C, and D. Okay, how can I do A? Let me go ahead and do A first. Okay, now that A is complete, how can I integrate B with what I have with A? And then you move in chunks. So getting that sort of, putting that ego aside and being able to say, hey, let me give myself the grace to be able to actually get to a solution before creating the perfect solution or the best solution. Just putting that human nature, that ego aside, will be really crucial to you when you're growing and developing your programming skills. You can find more details about passing the course on the page on grading. So I'm pretty sure it'll take you to this tab here. The exercises are not in any specific order of difficulty. Each section usually introduces some new programming concepts, and these are then practiced with both simpler and more complicated exercises. If you come across an exercise that feels too difficult, move on to the next one. You can always come back to the more difficult exercises if you have time later. Again, this is very collegiate. When I was in college, learning programming, some exercises felt a lot easier than others, even though the topic that we learned was probably very difficult. And some exercises were a lot harder, even though it felt like the topic we were learning was a lot easier. So there's really just no gradual buildup in difficulty sometimes. Sometimes you just get a hard exercise and you have to do it. So again, like I said just a few moments ago, sometimes putting that ego aside and saying that you can take on any challenge ever it will be very helpful for you to be able to say, hey, this is kind of challenging. Let me go on to the next one or come back to it later once I have some time to think about this so I can see if I can actually attempt it. When the going inevitably gets tough, a word of consolation. A task that seems impossibly difficult this week will likely feel rather easy in about 4 weeks' time. Yep, words to live by. Always give yourself time to work on these stuff. You don't have to, unless you're in a rush, right? I know somebody commented saying that they wanted to do this in like a month, to finish the whole course in a month, or the exercises, or just be ready enough to take the exam. You can rush and go ahead and do it. Again, if you just plan accordingly and you practice it as often as you can. But just give yourself the grace and the time to be able to make mistakes and come back and learn and continue to grow. If you have any questions, if you need some advice, leave that in the comments below. Otherwise, let's get started with this part, lists with different types of data. In the previous part, we mainly handled lists with integer items, but any types of values can be stored in lists. A list of strings could look like this. And I think we've covered lists with strings in it before. I don't know why they mentioned this, but I'm pretty sure that even in their examples, we've had lists with strings in them. But anyways, here we have a variable called names, which is assigned this list of strings, Marilyn, Ruth, and Paul. We call the print function. We passed names to that as an argument. And so we know that our code is going to print, our program when it's executed is going to print this list of names. Then we call the append function that exists with lists in which we can add an item to the end of a list. So when we call names that append David, then our list is going to be Marilyn, Ruth, Paul, and then David. So it's going to be 4 items in it, and then David's going to be the last item. Then we call print again when we pass names as the argument. So that's what's going to print, Marilyn, Ruth, Paul, and David. Here we call the print function when we pass these 2 arguments. The first is a string, number of names on the list, followed by the length function, which you can pass into it a list, a string, and it will get you the length of that item. So we know it's going to print 4 up until this point because we've appended 1 more item to the list. Then here we say print names in alphabetical order. We call names.sort. So names.sort, when you call it like this, it's Python, without passing any arguments, Python is going to sort whatever values we have in this instance in some ascending order. So if we had a list of integers, for example, and they were randomly jumbled, like a list of integers from like 10 to 20, but they were all jumbled. So you go maybe 11, 12, then 10, then 14, then 17, right? So they're all out of order. If you were to call the sort function on your list, then it's going to put them in ascending order. So in this instance, it's going to sort Marilyn, Ruth, Paul, and David. So David's going to be the first item, followed by Marilyn, followed by Paul, and then Ruth at the end. So here we call the sort function on the names list. And then we have our loop, which is going to then loop through the names list. And for each name, just print the name. So we sort the list first, and then we loop through it to print the names that would have been sorted. So our first print statement here just prints our original list, Marilyn, Ruth, and Paul. We append David to our names list, and now David, when we print the list of names again, David is now added. It's our last item in the list. Then we have this print statement here. Print the number of names on the list, which is 4, which is what we know again, Marilyn, Ruth, Paul, David. That's 4. And then print the names in alphabetical order. After we've called this short function, then we go to the loop and it prints. So it's going to do David, Marilyn, Paul, and then Ruth. Here we have a list. This is going to talk about floating point numbers. Floating point numbers are also valid list items. Here we have a variable called measurements, which is assigned this list of floating point numbers. It's again out of order. Actually, part of it isn't. It is. No, it's not ordered. Right? We start with negative 2.5, then 1.1, then 7.5. Excuse me. 14.6, 21, and then 19.2. For measure in measurements, print measure. So again, we're going to loop through this list of measurements, floating point numbers, and then for each index, we're just going to print what value is at that index. So it's going to print negative 2.5, then 1.1, then 7.5, and so on and so forth. Then we can calculate the mean by calling the sum function, passing it the reference to our list, divided by the length, calling the length function and passing in that reference to the list again. So the sum function, when you pass a list, is just going to add every value inside the list. And then the length function, as we've seen it before, is just going to return you how many items are in the list. And we know to find the mean, we just do all items added divided by how many items there are. So then when we print the mean, it's going to give us 10.15. So again, this is just us printing each item in the list, and then this is printing the calculation from solving for finding the mean. Okay, reminder using global variables within functions. We know it is possible to assign new variables within function definitions, but the function can also see variables assigned outside of it in the main function. Such variables are called global variables. So this is talking about variable scoping, right? If a variable is defined inside a block, right, inside of if a function, for example, then it only exists within that function. But if a function is created in the same file, I think this might be an easier way to think about it. So if you have let's go to the Python playground 1 second. Let me open that up on another tab. Okay, we have our handy dandy Python playground opened up. So you can see right here in this main that we're in this main.py function, file. So let's say, for example, I was to write a variable called names. Am I not typing? Okay, something's wrong. Let me refresh this. Okay, so say, for example, I created a list of names here, and we write Mike, Dean, Lorenzo. Then I define a function called print names, takes in a list, and we do for name in names in name list, print name like that. And then here I can okay, so let's go down here and let's call that function print names and call names and pass names as the argument. If I run this, it prints Mike, Dean, and Lorenzo. But say, for example, I also wanted this function to print the entire list as well. But this names list is not defined inside the function. But Python will still recognize it. So I can still do print entire list of names like that. And then just pass names. And when I run it, you can see that I still have access to this names variable. This names list inside of this function. But say, for example, I define a function in here called say hi. And I say hi like that, right? And if I was to then go outside of here and say print say hi, we get this linting going on, right? Python is telling me, hey, wait a minute. This is a local variable say hi. It's assigned but never used, right? Local meaning it exists only inside of this print names function block. So down here, when I try to print say hi outside of this function block, guess what error I get? Undefined name, say hi, right? Because in the global scope, this isn't available to us. But if it was defined outside of this function, like that, like how the names list was, then I can have access to it. And I also have access to it inside of this function, like how we just did it here with the names list. So that's what this is talking about. So let me bring that back so you can see it again. Right, so this is what this section here is talking about. Using global variables, right? Function can also see variables assigned outside of it in the main function. Such variables are called global variables. So when you define functions outside of certain code blocks, like functions, for example, they're called global variables because they exist to the whole file. And so any function, any if statement, any loop will have access to those. But some other types of blocks, like functions, and you define a variable inside of a function, that variable is now not available to the rest of the file or the rest of the code file. It only exists inside of this function. Okay, using global variables from within functions is usually a bad idea. Among other issues, doing so may cause bugs which are difficult to trace. So I don't necessarily disagree, but this is missing context. If everything is scoped correctly, global variables aren't a terrible idea. They're not a bad idea, I should say. But you want to avoid them a lot of the time because, again, they could cause certain bugs that are difficult to trace. But programming compilers and even just modern programming text editors like VS Code are very clever. They'll pinpoint exactly what's causing the issue majority of the time. So again, depending on the scope, depending on how big your program is, they're not too bad of an idea. If you're declaring them, for example, as to be helper variables and stuff like that in smaller programs, they're not bad. We've done this a bunch of times in our exercises so far. So this is usually contextual. It's very, very contextual. It's good practice to avoid using them, but again, it's contextual. Below is an example of a function which uses a global variable by mistakes. So here we have a function definition called print reverse. It takes in a list of names. And we have a comment here saying using the global variable instead of the parameter by accident. And we have a helper variable here called I, which is assigned the length of the list -1. While I is greater than or equal to 0, print name underscore list. Okay, so it's using the global variable here instead of the name so it's using this, right? Instead of referencing this, it's referencing the global list of names instead of referencing the parameter, the defined parameter of the function. So so let's actually put this in the Python playground ourselves so we can see what's going on. So when I run this, right, it prints, so what's going on first? Well, I is greater than equal to 0, print name, and then decrement by 1. So we want to print from the rear of the list to the front. So that's why it prints Paul, Catherine, Jean, and Steve. And then we call print reversed again, and it does the same thing. That's why we're getting the same two print values here. And then here, it does not print Huey, Dewey, or Louie. Even though both function calls have the right kind of argument, the function always prints out what is stored in the global variable name list. Right, because inside of here, because we're always, okay, now I see why it doesn't print Huey, Dewey, or Louie. Because it's always referencing this global variable, right? It's never referencing this, the parameter, right? If we were to do this, then this will still, so this will work, and this will work. There we go, now it's working. But because we hard coded, right? Because we're not using the parameter names, and instead of only are pointing towards this list, then that's where we get into this problem. But yeah, something like this, it's easier to, again, as you can see, it's contextual. This is easier to debug, so it's not really a problem when you do something like this. It's just, having to remember that you have to reference the parameter that's defined with the function. So that's what I mean when I say it's contextual. Like if it's a small program like this, it's not a big deal because it's easier to debug. But if it is a bigger program, then that might be a a big issue. And this is, I think, what they should have said to better explain why this might be a problem. If both function calls have the right kind of argument, the function always prints out what is stored in the global variable name list. To make matters even more muddled, remember that all code for testing your functions should be placed within the if name equals main block for the automatic tests. The previous example should be modified to this. Notice the global variable is assigned within the if block now. The automatic tests in the TMC system are executed without running into the code in the if block. So in this latter example, the function wouldn't even theoretically work since it refers to the variable name list, which doesn't exist at all when the tests are executed. Exactly, right? Because this now, basically these two exist in two different scopes. So it doesn't even have access to this. And we can see it. You'll see the errors when we paste it here. Okay, that's interesting. It's still running. So this is unique to the TMC environment, this kind of behavior where it wouldn't work because the tests are defined in such a way that basically these two wouldn't even exist in the same scope theoretically. But in any other environment, this will still work. You'll still have the same error is what I mean. Or problem. I shouldn't say error because we don't even, basically you still come to the same problem of misreferencing the parameter. Notice the global variable. We read this. The automatic test in CMC code and blah. So this later example. Okay, so we read this. Warning: overriding a parameter and returning too early. There are a couple of novel sources of bugs we should look at before jumping into the exercises in this part. Let's have a look at a function which tells us whether an integer is found within a list. Both are defined as parameters of the function. For number, in numbers, if number equals number, return true, else return false. This function seems to always return true. The reason is that the for loop overwrites the value stored in the parameter number. Thus, the condition in the if statement is always true. Right, so instead of referencing this, right, it's referencing this. So this is basically if number is itself, then return true. Well, yeah, if 1 is equal to 1, then 1 is 1. But if our number is 2, for example, it's not going to do 1 is equal to 2. It's going to do 1 is equal to 1 because it's referencing this number. Because now number exists only in this for loop, right? This reference of number exists only here inside the for loop. The function seems to always return true. The reason that the for loop overrides the value stored in the parameter number. Thus, the condition in the if statement is always true. Renaming the parameter solves the problem. I think it might even be easier to see this in action. So if we were to say, for example, numbers is equal to 0, 1, 2, 3, 4, 5, and then let's call number in list, pass numbers, and then we pass 4. So let's run this. I'm sorry, I should wrap this in the print function so we can see if it's true or false. So it's printing 4. Now you might look at this and say, well, is it? So let's write a number that's not in there. It still returns true, right? So what's going on here? I think this might be easier to see if we were to do print what number is. So first it checks 0. So it's saying is 0 equal to 0? In fact, we should actually print so we can see past number and then number. And then here we'll do print current number like that. So you can see that these two change. So we passed 11. So we say past number is 11. But inside the loop, when we start in the loop, the first number will be 0. So current number is 0. So now what this is happening here, it's not doing if 11 is equal to 0 or if 0 is equal to 11. It's doing if 0 is equal to 0 and then return true. So that's why this is always returning true. But if we were to say, for example, search number like that, and then pass search number, and then here, if we do number is equal to search number, and then return true, right? So current number is 0, right? And we already returned true or return false. So this kicks us out regardless outside of our loop. That's why it's only running once. So we might need a way to say if number is equal to search number, right? Found is equal to 0, like that. And then here we can say if number is equal to search number, set found equal to number. And then so this is just an error. It's not an error. This is working. It's just for whatever reason the Python playground has this weird linting issue where it's marking this as a problem. But this is going to work, but we're still going to kick out early here. So let's run this, right? It's still kicking out early because so basically if number is equal to search number, then set found equal to number, right? If this is false for the first number, for example, if our first number, for example, is 11 like this, where a number that doesn't exist, then it's going to do else return false. So it's going to kick us out of here immediately. In fact, it's going to kick us out of the entire function, right? So what we just need to do here is remove this and then return found, like that. Now we have that. Also, that linting error goes away. So now when we run this, even with a number that doesn't exist, we're going to see it loop through the entire list, right? Past number is 11, current number is 0, right? Then current number is 1, 2, 3, 4, 5, and then it returns 0 because that number doesn't exist. But if I was, for example, say 4, there we go, it returns 4. Because 4 does exist, so it returns that found number. So yeah, so this is the problem with this, right? First, in here, number gets overwritten, so it's no longer referencing this parameter number. It's referencing itself, so it will be 0 is equal to 0, and also because we're using these return statements too early, right? Since this is always going to be valid to true, it's going to return true and then kick us out of the loop and the function. Here, even if it's false, it's going to do the same thing. It's going to kick us out of the loop and the function. The function seems to always return true. The reason is that for the for loop overrides the value stored in the parameter number. Thus, the condition in the if statement is always true. Renaming the parameter solves one of the issues. This still doesn't go through our entire list, right? Changing this will still return true. I mean, will still kick us out even if the number does exist. I'm sorry, if the number does exist, right? So hopefully that makes sense as I've demonstrated in this part here. I say, for example, actually no, it does not work properly. If I were to say 4, okay, so now it's just returning false. Right, so it's still kicking us out on the first iteration. In fact, I think it might be better to do this. For us to do that, so we can see what values they both are. Right, current number is 0, search number is 4, it's returning false. Right, so even if the number exists inside of the list, it's still going to kick us out because we're using this return statement too early. But if we were to do it like what I demonstrated earlier, right, set found is equal to 0, then set found equal to search number. Actually, found is equal to number, like that, right? And then get rid of this. Whoops, excuse me, I did not mean to do that. That's a problem with my keyboard. Let me just unplug it and plug it back in. So then if I was to return found, like that, now this works, right? Current number 4, search number 4, and then, but the only issue with this now is that it's going to run through the entire list before returning a number. Right, so if we actually, in fact, we might just have to return true here. Otherwise, return false. So now we might not even have to do any of this. There we go. So it found, so it went up, it started at 0, then went to 1, then 2, then 3, then got to 4, and then it returned true and kicked us out. So we don't have to go to the very last value, right? So you can do it this way. So this fixes that problem, or you can do it with the other way, in which we set a helper variable in here called found, set that equal to 0. If number is equal to search number, set found equal to the number, and then return found down here instead of returning false. So you can do it this way, right? But if you do it the other way with the helper variable, it'll just go cycle through the entire list first, and then return what number that it found, that if it exists inside the list. But this way, as soon as it gets to that number, boom, it's just going to say, hey, true, and then kick us out. Now the condition in the if statement looks better, but there is a new problem since the function still doesn't seem to work correctly. Trying out the following manifests a bug, right? So found is equal to number in list, print found, it prints out false. The issue here is that the function returns too early, right? That's what I was just trying to demonstrate in this example. Without checking all the numbers in the list. In fact, the function takes only the first item in the list and returns true or false, depending on its value. We cannot know whether that number is not present in the list until we have checked all the items in the list. The return false command should be placed outside of the for loop. Boom, down here, just like what we just did. Now this will run through the list. We'll run through the majority of the list until it gets to, if the number does exist, it will work until, and this is one of those time complexity kind of questions, right? Well, you have to think about when you're writing an algorithm or a function, right? In one instance, would a list like this return true but cycle through the entire list? And that instance will be if the number that we're looking for is the last thing in the list. So if we were to do number is 5 and we were to run it, now we can see it cycles through the entire list before it returns true. Or if the number is not in the list, right? So if we don't have a number that's not in the list, if the number that we're looking for is not in the list, then we'll have to go through the entire list, right? And this will work the fastest if the number that we're looking for is early, it shows up earlier in our list. So boom, we just go through the first item and then we return if this number that we're looking for is 0. So when you start doing exercises that, or just leak code and stuff like that, where you have to think about some of these complexities like that, well, not necessarily time complexity, but sort of if our functions are efficient, right? These are some of those cases, edge cases, not edge cases, but some of those test cases that you have to think about whether we can improve our solution or not, right? So the solution is great because as soon as it gets to the number that it finds, it kicks us out. However, if we're to measure time, then if our list was, say, for example, 10 million values, and the number that we're looking for is the 10th million value, then this is going to have to run for every item in that list. But if the item that we're looking for is like item number 5 in the 10 million long list, then this will be a very fast solving function. So I think that's a pretty cool thing to think about in moments like this. Let's have another look at a faulty function. Well, it's a lot of yapping. I think this might just be a video on, we might just have to do one exercise. I might have to chop this up a little bit. In the next video, we can do the next one because we're already like 40 minutes into this video and we haven't even covered the first exercise. Okay, let's have a look at another faulty function. Here we define a function called unique numbers, takes in a list of numbers, a helper variable to store all the numbers we've already checked. So we have here another list called numbers, which has this empty list. For number in numbers, have we seen this number already? If number in numbers return false, numbers that append number return true. So what's the problem? As you can see, our parameter is of type list, but here we also define another empty list called numbers. So it's almost what it's doing is kind of taking this list of numbers and then reset it. So now this list is going to be empty when it's inside of the function. So I can copy this. I'm going to just comment this out. Let's run this. So it prints true. But let's say, for example, here we want to print numbers for every instance. Right? It's printing. It's printing something empty, right? In fact, it's not even printing anything. It's just kicking us out and returning true. So even if we pass a list here that has values, maybe it might be better to print numbers outside. So there we go. Boom, it's printing our empty list. Because numbers now, once it's inside this function, numbers is our parameter name and it's also this helper variable that we've defined inside of this function. So Python passes a list. The list could have values like it does here. But as soon as that list gets inside of here, boom, it gets reset into an empty list. So now when we do for number in numbers, right? Well, there's no number in here. So it's just going to, it's not going to be able to do anything, right? It's basically going to compare nothing to nothing. And so it's just going to return true. And again, we're not appending anything because, again, there's no numbers to append. And then it's just going to return true. The function is supposed to check whether all numbers in a list are distinct from each other, but it always returns true. Here, the function again overwrites the value stored in its parameter by mistake. The function tries to use the variable numbers to store all the numbers already checked, but this overwrites the original argument list, again, which is what I was just talking about over here. Renaming the helper variable is an easy fix. Right, so now we can change this to numbers checked, like that. Now here we can do numbers checked that append. Right, if number is in numbers checked, return false, otherwise append it, and then keep doing that, and then return true. So let's run this. I'm sorry, for numbers in numbers checked, right? Is that what they did? No, if number is in numbers. For number in numbers, if number in numbers checked, return false, right? If that number already exists in here, then don't do anything. Otherwise, append, right? Numbers checked that append number, and then return true. Right, so I guess I don't want to go in a little bit deeper on how to make this actually work. Right, so, but yeah, I mean, if we're just talking about why it isn't working, then yeah, that's why it's not working. Because when we pass numbers, and our list name here is also numbers, and it just overwrites this. But we're not returning the final list, but I think it's kind of weird. Again, I guess I should have explained what this one of this function to actually do. The function you just use number of store values already checked, but this overwrites the original argument list. The current list is 1, 2, 2. For number in numbers, if numbers is in numbers checked, return false. Right, so the first value is not because this is enter. So we should append numbers checked to append. Is it going to append 1? Okay, so it appends 1, then it appends 2. Then when it gets to the final 2, okay, that's why it's returning false. All right, cool. Now this is what we're working on. Why it's returning false is where we can see it. Right, because 1, right, so it checks through 1. 1 is not in the list, so it appends it to our numbers checked. Checks 2. 2 is not in there in the numbers checked list, so it appends it. Then it checks another 2. That already exists, so it's going to kick us out and return false. Okay. Problems like this, I mean, so this is, again, we've seen this in the past. If you want to use it, it's really helpful in walking you step by step in what a program is doing in Python, Java, C, C++, and JavaScript. I'm not going to use it in this video, but it's pretty helpful. Here we have our first exercise of this section. I'm going to just do this exercise on video now, and then I will do the rest in the next video because we've already done about 40 minutes and we haven't done any exercises. But after this, the readings get kind of short. Do they? No, they do not. But yeah, we should get to, after that, the exercises are pretty close. So I think we should be able to go through a couple of these exercises in the next video, maybe just finish all of them. I just want to ease my way back into making these videos. So for now, I'll just do this one exercise here on video. And then after that, the next video will cover the rest of this section. Okay, here we have our first exercise called the longest string. It says, please write a function named longest string. It takes in a list of strings, which takes as its argument, the function finds and returns the longest string in the list. You may assume there is always a single longest string in the list. An example of expected behavior. So we are going to use this. If name is main, then strings, hi, hello, howdy doody, hi there, and then we print longest strings. So we need to define this outside of this block. Okay, let me get VS Code set up and then I'll get back to you. Okay, VS Code is up. As you can see, I have exercise 1 in section 5 open called the longest string, which is what we're working on right now. I also have the rest of the exercises in this section, in this first section in part 5 opened. It's just the first exercises. So you can go ahead, hit the TMC tab, go to the Python course, scroll down to section 5, and then open the first 7. Or you can just download all of them and have them open for your end if you can manage it. I'll just have the first couple opened for us. Just zoom in a bit more. Hopefully that's close enough. I'm going to shrink this a little bit. In fact, I'm just going to close this sidebar so I can have a bit more room to write our code. So we know we're going to need this code block. Just going to paste that there. Then we're going to define a function called longest. Takes in a string list, which is a list. Then we're going to, just for the sake of making sure that our function works, just going to say current list of strings, and then we're going to print the strings list like that. Let's run this. Hopefully I don't lose any frames. I've already dropped like 40 frames. Okay, there we go. Just prints hi, hello, howdy doody, and hi there. So we need to return a string, which I'm assuming, if I read the, yeah, it's going to return a string. So we're going to say here current, or just say, yeah, current longest is equal to an empty string for string in strings list. And we're also going to do current length is equal to 0 if string, I should say length of string is greater than current length, then set current longest to the string. And then we're going to return current longest. So I'm just gonna comment that out. Let's run this, see what happens. Okay. How many got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's not. It's returning hi there, but the answer should be howdy doody, not hi there. That's if length, right. So this needs to, if length of string is greater than current length, then we need to set current length to length of string. And I think this should work. There we go. Now we got howdy doody back. So I'm going to remove this. So I'm just going to rename this like that, just to keep some symmetry with our variable naming convention. So again, if I run this again, we get howdy doody. Let's run our tests on this code. And And there we go. Send those solutions to the server. Passed. Refresh. There we go. Go back to VS Code. Open the model solution in the browser. I've already logged into the TMC website, and there we go. So they did the same thing. They have this helper variable here called longest, which is initialized as an empty string. Then for item and strings, if length of item is greater than the length of longest, set longest item. Actually, this is what I was trying to do here with this second helper variable, but we did it with two helper variables. So we can do it this way too, where if length of the current string that we're looking at is longer than the length of longest, then we do that. So we could do length of current longest like that. This will still work. So let's run this. There we go. It still returns howdy doody. So this is even a little bit shorter of an answer. So yeah, we have these two solutions. The first one, submit both of them. You're still gonna get credit for the first one because we got it right. But so you can do it this way, which is again a lot more streamlined, or you can do it the other way, where you have current length, set that equal to 0. Then if length of string is greater than current length, then set current length equal to length of the current string, and then set the current longest string to the current string that we're looking at, and then return current longest. This also works, right? So, but I'm not gonna send the solution to the server. So I'm gonna when I upload the solution to GitHub, the file will have both of these answers. It's going to have this one, and it's going to have this one right below it, because yeah, it works. So yeah, I hope you guys liked this video. 51 minutes. It was a lot of yapping, honestly, a lot more than I thought I was going to be doing. But some of the material that we read, it was a little bit of a refresher rather than new material, so that's why. And I figured I could throw in a couple of my 2 cents in just ways you can move forward when you're taking this course, right? The kind of mindset you should have, being able to put aside your ego and be more open-minded. It's okay to fail. It's okay to get a solution wrong, as long as you just continue to chip away at it. If an exercise is too big of an exercise for you to take on at one time, trim it down into chunks, right? Do one part at a time and see how that goes for you, and then try to work in the entire solution. It's always good to get to a solution, all right, that works, as long as you just get to the expected output and then go back in and start revising, like what we did, right? We had a solution that worked. We compared ourselves to the model solution, and the model solution was just a tiny bit more straightforward. It's a little bit simpler, more straightforward. So we went in and we revised it a little bit. Even though our two solutions did the exact same thing, I just like the model solution a bit better. So that's what I'm trying to have you guys think of how to approach some of these problems, right? Try and see if you can get to the solution first. Then then you can go back and challenge yourself. In fact, you can even just go through the entire course and just submit one solution for each exercise. And then once you go through the entire course, or maybe you just want to do it like section by section. So you go through section 1, then you go through section 2, 3, 4, 5, etc. And then for each section, right, you go through all the exercises, all the subsections, right, all the parts. Like part 1, you go through all the sections in part 1. And then you go back, once you submit your solutions, go back and start from the first exercise and then see, hey, this is how I did it the first time when I visited this exercise. What's another way that I can do it? Maybe that's something that's a little bit more efficient or a lot simpler or a lot more straightforward, right? Because now you know more tricks. So you can, or more shortcuts, more efficient techniques and whatnot. And your brain just has a little bit more folds in it, right? Your brain isn't as smooth as it was when you first started the course. Right? You have a bit more wrinkles in your brain now because you know how to do some of these things a little bit more efficiently, a little bit better. So you can go back in and say, hey, how can I rework this exercise that my solution was very, very long to? How can I make it a little bit shorter, a little bit more straightforward, and things of that nature. So if you just put that instinct to always want to get the right answer first, or to get it right the first time around, you will go very far as a programmer. So thanks so much, guys, for watching. The next video will be up in hopefully a day or so, and in that video we'll cover the remaining exercises and reading inside of section 1 in part 5. So thanks so much for watching. Go check out the GitHub repository. Both solutions will be in the uploaded solution. If you have any questions for me, if you have any questions or issues that you're experiencing as you're taking on this course, don't hesitate to ask. I've gotten so many different kinds of questions so far, which I always welcome questions, and I try my best to help anybody out. I had a person in my comments ask for help on how to get the TMC extension working on their installation of VS Code, and through some trial and error, I helped them get to a working state, and now their TMC extension is working. So no question is too small or too big. If I can be of any help to you guys, to help you guys have an easier time doing following along this course, then just ask away in the comments, man. I'll be more than happy to help you out. Okay, I'll see you guys in the next video. Enough yapping from me for today. I'll see you guys in the next video.